Welcome back, Math Marvels. In today's lesson, we're going to practice dividing when there's a decimal in our divisor. Our model for today is going to have decimals in the divisor, so I want to very quickly share with you how we deal with this problem. You're going to see me do 3 steps, but let's take a little step back so you can see what the problem actually is. What if I try to do 6 5/10 into 117 if I tried to divide this? And I would normally go in through my first step. 1 divided, I can't do. 11 divided by 6 5/10 is 1. But what happens when I get to multiply? What is 1 times 6 5/10? 6 5/10. How do I do 11 minus 6 5/10 here? Do I do this to subtract? Does that make sense for a subtraction? How does that even, where would I even borrow from? It doesn't make sense. So, or do I do, let's see, this to subtract? And I still have the same problem, where does the decimal go? Do I take from the 7? This just doesn't work, Math Marvels. There's no way to somehow subtract. So, we're not doing this one. And I'm going to show you the convention, the very quick thing that people do in order to do the subtraction problem. What they do is, and I'm going to show it as a fractional one just so you can see it, is we're going to move that decimal. We're going to shift them like their partners. So first, let's make sure they both have decimals, and you're going to move 1 to the right. You're going to keep moving to the right until it's a whole number. So 65, and you're going to do the same thing to your dividend. They're like dance partners. They're moving together. This is a problem that we can solve. So those are the 2 steps you're going to see. You're going to use multiplication to convert the whole number. And you may be thinking, Sarah, I don't see any multiplication there. Well, it's hidden, because when you move a decimal 1 time to the right, you are making the number 10 times bigger. That's right. You didn't even think about it, did you? But just moving that little dot over to the right made it 10 times bigger. And you did the same thing to your dividend. And you're supposed to do that because that is what keeps it balanced. They have to both grow in the same way so that your answer doesn't change. So those are the first 2 steps I want you to think about. When you get a decimal in your divisor, you're going to move the decimal to the right until you have a whole number, but you are also going to move the decimal in your quotient the same number of times. And that is how we remain balanced. I'm going to give you another example here. 2 and 853 thousandths is going to be used to divide by. How do I make that work? Again, you're going to think, how many times do I have to move the decimal to make this a whole number? 1, 2, 3 times. It takes 3 shifts to have 2,853. How many times bigger? I want you to really think about this mathematically. How many times bigger is this then? 10 times, 10 times 10 times, 10 times 10 times 10. So 10, 100, 1,000 times bigger. That's what's really happening in this problem. And you're going to do the same thing to your dividend. We're going to add a little decimal in there. And it's going to look funky in the beginning because there's no numbers there. 1, 2, 3. And you're going to put the placeholders in there. 1, 2, 3. This is a problem you can solve because now they are both 1,000 times bigger, and we can do that division. We could not do that division when there was a decimal in a divisor. So those are 2 steps. I want you to add those to your notes, and I also want you to just be aware we're not using R as a remainder anymore. Instead, we're going to keep on dividing. If you have anything left over when you divide, add a 0 and a decimal point and keep on going so you can divide until the nearest hundredths place. Jot this down into your notes, and we're going to get into today's model. Let's put those dynamic decimal division skills into practice with this first problem. Jared, uses 132 and 72 hundredths ounces of apple juice in his fruit punch. A lot of fruit punch. If for every orange added, he uses 8 4/10 ounces of apple juice, how many oranges will he need? So that if statement is really important to just think about, because it means every time he puts one orange in, he has to put in 8 4/10 ounces of apple juice. So there's a ratio there that we're going to look at and talk much more about when we do our next unit. So what is the problem asking us? Let's go back into solve. We want to know how many oranges he needed to make fruit punch, to make all that fruit punch. And here are facts. We know he used 132 and 72 ounces of apple juice in the punch, so we know that amount. And we know that for every one orange, he uses 8 4/10 ounces of apple juice, and that is our ratio. So here's my plan. I'm just going to take that total of apple juice and divide it by 8 4/10 ounces, because that's the ratio. Every time I add one orange, every time I have 8 4/10 ounces. So I'm just going to figure out how many sets of 8 4/10 ounces are in 132 and 72 ounces. So that's what we're going to put into practice. You notice there are decimals in both the divisor and the dividend. So hit pause, jot this down in your notes, and let's get into our plan. Okay, so here is our plan. I'm just dividing 132 and 72 hundredths by 8 4/10. And we know as I translate this into traditional division problems, I don't want to divide by 8 4/10. So I need to think again, what do I need to do? And I'm going to just put this here on the side for you so you can see my thinking. So I'm going to rewrite this. What would I have to do to turn this into an 84? I need to multiply it by a magnitude of 10 to make that decimal move one time. So I'm multiplying this number by 10, and that means I'm also multiplying my 132 and 72 hundredths by 10. So I'm really going to do 1,327 and 2/10 divided by 84. That is, I want you to clearly see where I'm getting those numbers as I do my traditional long division. That is just where my numbers are going. Now I'm going to put in 84 as my divisor and 1,327 and 2/10. I'm also going to line up my decimals in my dividend and in my quotient so we know it's there. And as an additional reminder, we know that if I have 1, 2, 3, 4, 5 digits in my dividend, I should also aim for 5 digits up here in my quotient, even if I'm using a 0 as a placeholder. It's a very simple place where kids sometimes make place value errors. And we're going to do our divide, multiply, subtract, bring it down. Another thing you're noticing on this page right over here is that I've already prepped and put in my multiples of 84 because I don't know the 84 times tables by heart. And this way I don't have to think in the moment. I can just use my list when I have to divide and multiply. So there you have it. Now I'm ready and good to go. So we're going to start with the first step. Divide. 1 divided by 84. 0. So I'm going to put that digit right there on top and go to the next one. Now we're thinking of 13 divided by 84. 0 again. Can't do that. I don't have enough, but I should be able to do with this one. 132 divided by 84. And I can just look at my list right over here. See, look, see. When I look over here, I can see that I can do 1 set of 84s. I can't do 2 because I don't have enough. I don't have 168. So I'm going to put 1 here, divide, multiply. 1 times 84 is 84. Subtract. I'm borrowing over here. And I have 48. And bring down the 7. And look at this number, 487. Ooh, it's ugly. And if I had to sit here and do how many 84s go into 487, I would do a lot of estimating. But luckily I have my little list, so I'm just going to skip count. How many 84s can go into 487? 1, 2, 3, 4, 5, not 6, so 5. So I'm going to put my 5 up here. And now I could just do 5 times 84. And oh no, I don't have to do that multiplication because again, I could use my little list right here and put 420. And subtract. At least remove 67 and bring down the 2. Now I'm going to divide again. How many 84s go into 672? Look at the list, count it out in your mind. 1, 2, 3, 4, 5, 6, 7, 8 times. And just multiply. And again, looking at my list, I can see that it is already 672. And there we go, we have 0. So my final answer is, my solution is 15 and 8/10. And let's put that in context. He will use Jared, full sentence. Jared uses 15 and 8/10 oranges. Now, does that make sense? Let's think about this, Math Marvels. Can I just use 15 and 8/10 oranges? No, I'm going to need to round that. 16 oranges. To make fruit punch. That's where this really matters in terms of context. So 15 and 8/10 oranges. We know we're not really going to just use a piece of an orange, so we really need 16 oranges. So we're going to hit pause, jot this down into your notes. Great job. And just think about all the different things I did in order to make this process easier for me to work through.